Hi, and welcome to the Selected Tech podcast, brought to you by a group of 4 MVPs doing webinars, sessions, and interviews on all things SharePoint, Office 365, and the Microsoft AI ecosystem. Their motto is learn, share, reuse. And here they are, Albert-Jan, Rick, Stefan, and Tommy.
Hi, welcome at another episode of the Selected Tech podcast, or webinar actually. Tonight we're going to walk you through running your AI model in a on-premises SharePoint environment. So, as normally we are 4 guys, today we're slightly different. We kind of switched out Stefan, he couldn't make it, so we invited Rutger. Rutger, tell us a little bit about yourself.
Yeah, so I'm Rutger. I normally introduce myself as Roger because the G is Dutch. It's kind of hard for some people. So you could call me Roger. I'm a technical cloud consultant at Portova in the Netherlands. And a few years ago, I graduated and I started doing some cool things with AI.
That sounds good. That sounds good. So what are we going to talk about today? Today we're going to talk about using AI to classify your SharePoint data. And we actually call it a love story, right? Because we've been working on this project together.
It was a love story, yes.
Yeah, it was. So basically what we did is we played around with entity extraction, we played around with language detection, and we did things with custom learning. So it all sounds pretty cool. And tonight we're just going to walk you through some of the key concepts that we used, that we applied in this process, and well, try to get you enthusiastic about all the cool stuff that we've been playing around with lately. First, you probably heard about Project Cortex, and Project Cortex is a new service Microsoft will be releasing, and they position it as basically the next step in knowledge management in SharePoint. And what they do is they do image and text recognition, form processing, and machine teaching. It all sounds really, really interesting. Basically, it's applying AI to the data that you already have in your SharePoint environment. And what they do with that is they create so-called knowledge entities, and that knowledge entities will actually be fed through experts. So it's a combination between AI and a, let's say, curated set of content that you can generate. That knowledge entity then results in something called a knowledge card, and that knowledge card is probably familiar. We all seen the people card, we've seen the share card. You just hover over a link and it will show you, it will give you an indication that what you're hovering is actually knowledge, and within that card you can actually see some details about that knowledge, so related documents, experts that are related to that knowledge, and you can click through, go to the topic page, which is basically the extended version of your topic card. All those topic pages are available in the Knowledge Center, where you can actually generate, or where you actually can see all the content that you would have. And if you would look how it, or if you want to have a look how it sees, you just go through your normal SharePoint page, you hover over a topic, that topic is recognized as being content that is relevant for you, and you'll see this nice topic card that you can get a glimpse of all the knowledge in your environment. Now, if you go there, you can actually go to your Knowledge Center, where you get an overview of that topic page, where you can see an overview of the content, of the people, of all the resources, so all documents, all sites, related topics that are related to this specific topic that you're looking for, questions and answers that are coming from Yammer, and additional project details. So there are quite a few things that make up Project Cortex. Last one, you see here a sample actually coming from the Azure portal, but it's the form recognizer, and the form recognizer allows you to get a PDF file or a Word document and actually extract key value pairs. So it recognizes that specific parts of the document, even though it might be PDF, can actually be translated into a key value pair, where the first one would, the key, describe what you're actually getting, and the value is actually the actual value in the document. Meaning that if you have a bunch of files that look the same, that you can actually extract that content and apply that content that you extract from it as metadata to your file. So you could say, if you have your invoices, you can actually go through all your invoices and have the customer that the invoice is for, or invoice is actually coming from is something that you want to apply as metadata. So you can apply search, you can do find and well, anything basically that you can do with metadata, right? Filtering, sorting, stuff like that. The thing with all those services is they're all in the cloud. So it's all Azure, all Office 365. And even though that's awesome, there still are customers running hybrid or running on-premises. There are use cases where you're not allowed to go to the cloud. And that's a thing, right? So what if you are running in your organization a SharePoint farm that's not allowed to the cloud, allowed to go to the cloud? So in our case, the data needs to stay on premises. There's no way we were allowed to go to any other services than their own network, their own infrastructure. So we had a case and we started working on this case. And that's actually what we're trying to present you today, the things that we learned working on this. Let's start with some of the key components that make up our case. First, customer had a large set of unstructured data. In our case, mainly Office and PDF files. Doesn't really matter what type of files they are. They were just a bunch of files. Let's say 10 terabytes, something like that. Maybe 20, maybe 5. Doesn't really matter how large the data set is, but it was quite a large chunk of data. And all the data was stored on a file share. So an old file share, they started dumping content to it years and years ago, never applied any structure. There are a few folders, but if it were 5, then it was much. So all data was like in that file share, poof, there you go. There was no configuration done on it whatsoever. So it wasn't searchable. They didn't apply full text search. So finding a document actually meant you had to go through, scroll down to a specific document, or use the exact file name to actually find the file that you were looking for. There was no metadata captured. So there was no additional content applied. So there was no way you can actually find something if you didn't know the exact file name. And a bunch of the files were actually scans of typewriter created data. So really, really old files. And then the last one, and that's the important one, legal requirements prevented us from actually going through the cloud. So we were not allowed to put our data in the cloud. We were allowed to do testing, so we were allowed to put a subset of our data in the cloud. So there was some discussion and we ended up with a subset around 1 gigabyte of content that we were allowed to use for training purposes in the cloud. And that's an important remark because that gave us some artistic freedom to actually experiment with different services in Azure before trying to mimic that behavior locally, because that's basically what we try to do. So really, really short. What did we do? We ended up with a network share top left corner. We actually used SharePoint and we created a SharePoint site collection where we configured a search center and the search center just crawled our file share. Easy win, just crawl a file share and you have full text search. Nothing fancy there, but you're good to go. The thing is, you can actually extend the experience in a search center. If the crawler hits a file, then there is actually something taking place, and that's called content processing. So before an item ends up in your index, there is something called content processing. The cool thing about content processing is it parses your document, the document parsing stuff, and then you can actually apply content enrichment. So content enrichment allows you to call your custom APIs or custom logic before things like word breaking or custom entity extraction happens. So what we did is in that content enrichment service, we called our own web service. With our own web service, we could actually say, hey, we've got a file. We already knew some of the things about the document because the document was already parsed by our crawl service. And then we could say, maybe we want to extract some metadata, or maybe we want to clean up the data a bit because we do not want to send the full document to our AI model, but we only want to send the first 5 pages, or maybe the first page only because we know that within the first page there's only going to be a title page or something like that. Then once we've cleansed our data, so we have a clean, or we've got the content that we need from the document, we can actually send it to Lewis, where within Lewis, you can use the intents and entities to actually extract value. So in a nutshell, that's basically what we did. We used SharePoint for full text search. We created custom content processing to inject intelligence into our search experience. And within our own logic, we could determine whether we could go to the cloud or not, or we could use Lewis to use the intents and entities and write those back into your search results. Because what happens, your web service in the content enrichment part will actually have to provide back to your search service the properties, the crawled properties that you want to work with. And those crawled properties end up in your search index, and those can be used as map properties. And if you create them, you can actually do the things that you normally do with crawled properties, like ordering, filtering, applying sorting, applying weights to it if you want to play around with that. So that's in a nutshell what we started working with. So what did we do with Lewis? Really short introduction. Rutger, tell us a little bit about what we do with Lewis.
Yeah, so Lewis is the Microsoft Language Understanding Intelligence Service, and it is a service that can understand context and actually extract entities or parameters, as you would like. And it basically contains three big keys, which is the utterances, the intents, and the entities. The utterances is basically what the user says. So that's the input for Lewis. In our case, that were documents, cleaned documents with the included metadata. And then the intent would be, what does the user mean? Normally, Lewis is used for chatbot situations. So for instance, if you want to book a flight to Chicago, 2 tickets, the intent would be book a flight, and the utterance would be that entire sentence. And last of all, we have entities, which is basically the parameters that is put into the utterance. So in this case, it would be 2 tickets to Chicago, Chicago being the location, such an entity. In our case, we only had one intent, and that was basically get us some metadata. So get metadata was our intent. And the entities would be whatever the description or the author or any kind of property that was included was, and we could return that to SharePoint. So in a nutshell, Lewis is a way to understand context and grab metadata, in our case, or entities out of it.
That sounds interesting. So Lewis is still Azure, right? It's not on-prem yet.
It's all in the cloud, yeah.
That's where it actually gets interesting. Basically, what you can do is if you create your Lewis model, you can train your model in the cloud, but then you can download a Docker container where the Docker container contains the trained image that you can use. So that's actually what we did. We trained our model in the cloud, and then we downloaded everything into, in our farm, we created a Docker container server and we ran our container there. In our demo, we just ran it on a SharePoint server, so it's demo purposes. But yeah, that's basically it. So
that's right. Yeah, it's the training of a model that takes like a lot of compute power, but running a trained model, it's doable, right?
Yeah, so the container, we'll show you in a second. The container is less than 1 megabyte that we actually get, or the model is less than 1 megabyte.
Okay.
So it's small enough. You need a 2 gigabyte or a 4 gigabyte image with some memory, some CPU, but that's basically it. Obviously, if you're hitting it with 10 terabytes of data, you might want to scale up a bit because, well, you're still servicing an API, and 10 terabyte is a lot of data. But for demo purposes, you can get like the smallest image available, and it works fine. So Rutger, can you walk us through the Lewis model first? Let's go there, see what we actually need to do, and download that model.
Yeah. Let me share my screen.
Cool.
So, can you all see my screen? Is it working?
Yeah.
Great.
You can
So
zoom in a little bit.
A little bit, of course. There we go.
Yeah, that's
Yeah, we are old. We need to have bigger phones.
No glasses, just zooming. So here we have our.
One final thing. Can you click on the little thingy next to my name, bottom right corner? There you go. I don't want to see myself.
Oh, nobody wants. So Here we have our Lewis on-premise demo app, which is an application in the Lewis portal. Again, this is all in the cloud. So what I'm showing you right now is all online. And here we have the get metadata intent. So what I did here is fire some utterances to Lewis, for example, with a description and with a location and then with an author. And basically, the blue line you see below it is the entity. So I labeled that entity. And I put some utterances, like 10 or 12 utterances, into this Lewis model. Then I trained it. And normally you could just, call the API and use Lewis the online way, the cloud way. So if you would like to use this entire model in an on-premise situation, you would have to download the image. And you could do that actually by going to Manage, then going to the Publish settings, Azure Resources. Then you have to make sure that you have a valid Azure resource for Lewis. This does not work with a starter key, for example, because billing does have to be enabled. So a valid key for an Azure resource has to be generated. Then if you go to versions, here you would normally have 3 versions, 4 versions, or whatever. You can select that. In this case, we only have 1 version, which is the 0.1. And we can export this. So this is the trained model. I trained it probably at 17th of June. And this is the version that's normally used right now. It's active in staging. So let's say this is the model we want to use in an on-premise situation. And normally for each iteration, so for example, a model has to get retrained all the time. You'd have to do this all in the cloud. But to use the image on your on-premise situation, you just have to click on export and then export for containers. And what this does, it's exporting, and then you get a nice .gz file, which you then can use in your Docker container.
So you're telling me that I can get a data scientist to do the things that he needs to do with Lewis and then just say, here's your container, go ahead.
So basically, yes.
Yeah, that sounds good. So as a developer, I don't need to worry about all the complex stuff, except that I only need to know a little bit about Docker, right?
Exactly. Yeah.
That sounds good. That sounds good. So let me share my screen again and go back to the presentation because we've got one more slide. There we go.
Am I allowed to ask a question in the meantime?
Sure, should.
You said something about licensing. Is this correct if I say that this Docker image needs to call out to Azure in terms of licensing, or is this really offline?
It's really offline. There's no connectivity, but what they do is they, in the container, they get the API key that you provide in your API call. And if that does not match the API key that you've gotten from exporting the model, then it says it's not valid.
Okay, but this means that you basically just pay for the generation of the model. If you're not touching the model for the next, I don't know, 5 years, you're not paying anything more.
That is correct. So you can still use your free key to actually do that. Within your subscription, it would work. And yeah, so far there's no additional costs for downloading. It's just the training.
Yeah, but you want to train your model again, though? Or you have to train it again, so yeah, something changes. And
you have to be realistic. It's not going to be training your model once and then you're going to be done for the rest of your life. It's probably going to be retraining your model based on the output, based on input from users. And well, it's an iterative process, I guess.
Yeah, it was more the question was because I compared it to, I think, what's called Azure Stack. Yeah. Where you have the option that you basically run the things on premise, but you give back measurement data so they can calculate the price, or you pay for the whole box for fixed price and off you go. That was my question coming from.
Yeah, so in this scenario, there's no, so you can actually block all internet traffic from your VNet, because we run this demo in Azure. We created a 3-server farm in Azure, and we played around with blocking actually every data from the VNet, and our model would still work.
Cool.
So,
that's cool.
So
still the Docker container is still an API that you have to call.
Yeah. I will show you in a second. Just really short on Docker. Containerized application. So what you will actually need to do is you'll need to have the Docker infrastructure in place. Docker has to be installed on wherever you want to run it. And then what you pull in is a AI image from Microsoft. And within that AI image, you can actually run your trained model. So if you do not pull that image, there has to be internet connectivity at that point in time. You have to pull it from the Docker registry, and then you can start playing with it. Obviously, there are different images available. Kind of depends on what you're running. If you're running in Windows, you'll need a different image than if you were running on Linux. For both scenarios, there is actually options available. So with that, let's go to our demo. So let me share a different screen. 1 second. There we go. And I will need to grab my Windows virtual machine. If all is good, you should be able to see my desktop, right?
Yep.
That looks good.
Yep.
That looks good. So the first thing that we'll need to do is we'll need to make sure that Docker is running, and Docker desktop is running. If you are working as we are currently in a Azure environment, if you use a SharePoint server farm, one thing to make sure is that Docker is actually running as an administrator. If it's not, then things will start failing. And I created some commands, or I put them in a text file so I don't forget them. Let me go to my font size it up a bit. So the first thing that you will actually need to do is you'll need to do Docker pull and then get the image that you want to run it. So we want to use the Azure Cognitive Services, and we want to get the latest Lewis image. Now, this is something that I already did because it takes like 2 or 3 minutes to download the image. The image is not that big, but it just takes a few seconds. Then once you have that image, you can actually run it. And here you see this is the command that you would use to start your image. And as you can see here, what I specify is the amount of memory it can get, the CPUs, and then I bind 2 parts. The first one is a input folder, the second one a output folder, and within the input folder, I actually have to specify, or I have to upload the file that I want to use as my model, and my output folder can contain verbose logging data. So what API or what did get called? Did we get hits? Did we get misses? What was actually the result from all the queries? Then things like you have to accept the agreement, makes sense. You have to specify your billing endpoint, and you have to specify your API key. Still makes sense. Once you run this, that means that you've got an API running. So let's try and see if everything is working. Let me do command prompt. I didn't install anything on this server, so no terminal, no. So it's just running SharePoint to show you that there's no smoke and mirrors. Once you've done that, we should be able to run this. Remark, because Docker is actually running as an administrator, anything you want to query against it, so whether it's PowerShell or command prompt, you actually have to run this as administrator as well. Otherwise, you get this nice error saying, yeah, you're screwed, we're not allowed. Now, there you go. It seems to be running. Application started, all good. Let me start a new command prompt. And that means that I can do curl, and I could just say, okay, let's try and hit my API. Because where is it running? Localhost 5000. You have to specify what version of Lewis you're doing. You have to specify your app identifier, your app ID, and then you have to specify what you want to do. Well, we want to predict something, and I specify my query, and I specify that's either verbose, whether lock has to be turned on or not. Just fairly quickly, let's see if we get results. if all is good, I wouldn't get any errors or red text, but you never know. Fingers crossed.
Yeah. And that's the same app ID that you're using in the cloud.
Yeah, same
from the export model. Yeah.
So here you go. What you can see is that I put in a query called test132, that there were no intents found, so the top intent is none, and it's quite confident that that's the actual intent that I tried to do. So as you can see, it's just calling this API with the data that you want to get your results for. Now, obviously, you can use curl, you can use basically anything. So what we did is we created a dummy list where in that dummy list, we just added a new item. So basically what I can do is I can create a new item here, and then I could use a webhook, or I could use something else to see what the actual Lewis result would be. So let me create a new item. Let's say another test. So Rutger, any tips on what I should use as description?
Oh yeah, I thought about this one. The grass is always greener in the other team's channel.
In the other team's channel. That's deep, man.
Yeah, I know.
Did I type grass wrong?
Yeah, it's double S. Yeah.
Second S is silent.
But yeah, that's new for me. Sorry about that. So there we go. Created a new item. And what I can then do, I just open a PowerShell window. We created a really small PowerShell sample where we just used the PnP PowerShell. We connected locally, we got the dummy list, and then for each item, we just fire away against our model and we set the result that we get. So if I would execute this, what this will actually do is, if all is good, will tell me, there we go, it found 3 items. And if you now go to your Lewis results, I could refresh my page, 1, 2, 3. Then you can see, hey, I've got my query. And if I go to this one, well, let's go to another test. And it did say, hey, we found the top intent get metadata. And it was quite confident, but it couldn't find any of the entities that specified. If I go to another one, the dummy title, then it couldn't find any entities as well. And if I go to the test one, then, hey, apparently it found description, even though within my description actually made a typo and I wrote description. So my model was smart enough to actually capture that from my error. So with this, it's just using PowerShell for demo purposes, but you could use webhooks, you could use, well, event receivers, you could use the search content enrichment experience. Basically, you can do anything with it. And obviously, in our real life scenario, we put in some logic, not necessarily just writing out all the Lewis results all the time, but we filter down on a score, so anything below the 80 we didn't process because we really wanted to be sure that what we've got was like really confident, a high confidence score. But yeah, in a real life sample, that's something that you want to play around with as well, right? You want to capture as much data as possible, and you want to, well, really think about how much data you can cover with your model. Anything I forgot on the technical side, Rutger? I think we captured everything, right?
Yeah, basically, yeah.
Let me make sure that I show this one. I can go to my Lewis model. Here I've got my input, and this is where the file Rutger just downloaded is actually placed. It's 185K. So
that's nothing. Yeah.
That's nothing. That's nothing.
And what's it structured like? It's JSON-like structure? Okay, open it up.
No, I can try.
Unreadable.
That's the big secret.
Yeah.
I'm just curious. Yeah, okay.
No, it's a CZ file. It's a zip file. You need 7 zip. It's a Linux zip file. I don't think that I'm not sure. No, she said this from Linux, so
okay.
It's not convertible. You would need 7 zip to open that on Windows.
Yeah, I was just curious. But in the online Lewis, if you come back after a while, it says, okay, I think that you had these and these utterances, and you can score them as well because I need to learn.
Yeah.
But yeah, with this you don't have that. Okay, you upload your output or something, no?
Yeah, good question. We didn't try that. I don't know.
No.
It does store output. So
Yeah, but yeah, maybe then you could use that output to, I don't know, upload it or retest it or something. That's the cool thing about Lua. It keeps on learning and learning and learning. So.
Yeah, that makes sense. So let me go, because I have installed 7-zip on my local machine. If I export that file, I get a 1 file. The 1 file is not really readable as well. I have no clue what that type of file is. There are some things that I recognize. I see my name, I see Rutger's name, but I see some really weird shit as well. So
it's just black box.
Something to put in one of those what's called model thingy.
Yeah. I don't know for Lewis, but I think for custom vision you could, or I think 2 years ago you could export it to 3 different versions. TensorFlow I think was one.
Yeah, those things.
And another one, I think TensorFlow was the Android based, and there is another one for iOS, because you can even, for custom vision, you can export the model and upload the model to your phone for those hello world examples like apples and bananas and detection of those things. That basically just run on your phone, because it's not if the algorithm is clear, it's pretty easy.
Yeah, as long as
I'm not sure if it was Build or Ignite where Scott Hanselman actually showed a JavaScript version of the game where they did it in a JavaScript library. So pretty cool stuff.
Yeah, but on your end, you probably need the container with a little bit more power, because the content enrichment service will fire the thing like crazy, or?
Yeah, if you have 10 terabytes of data, then you have quite a large data set, and you get quite a few hits. But it does depend on how much data you've got, I guess.
Yeah, the content enrichment is only on-prem, right? Yeah, it doesn't work online.
Yeah. So
it's age-old technology, or I think it's
2013,
or
it's fast. It's still fast stuff.
Yeah.
But it works, and it's really cool to see that you can extend that search experience with that way.
And did you have a comparison? Sorry for interrupting again, but a comparison between a full index with the content enrichment and a full index without, in terms of timing, performance, and
in our scenario, we actually a crawl without the content enrichment service took 4 to 5 minutes. After the content enrichment service, it almost took an hour, because the API that we called wasn't optimized. We didn't do anything. On the performance part, it was still running on the same box, because we just wanted to do the proof of technology, not necessarily the real production build yet. We did manage to get like 90% score on the content with our AI model, so that was pretty good.
That's cool.
And basically, if you bring this live, you'll just need another box where you can host your API, and where you can say, hey, my search is going to hit this API during a crawl 10,000 times per minute. Let's scale it up a bit.
Yeah, because both operations are CPU intensive. File read.
File read
for your CPU.
But it's pretty straightforward. What we do? We created a Lewis model. We started in the cloud. I really like the fact that it is so easy to start. I'm not a data scientist. Rutger did graduate on the AI part, so he actually understands what he's doing. I'm just clicking in a portal and watch the webinar. I'm like, okay, I understand the basics, and all of a sudden I can do the things that I need to do. Basically, then it's just training and publishing your model, downloading the model, installing some Docker parts that takes 5 minutes. Then start your container with the downloaded model, and then you're good. Then you can connect it from PowerShell, webhook, search, custom code, whatever you think is needed. And that's just it.
Yeah, that would be a very cool scenario if you, I don't know if it's possible, but now you're using Docker, you can basically just switch out the image with another configuration. So this means you can probably use what Amazon has to offer or what the Google Cloud has to offer to compare the different models or services that are out there.
Yeah, so the last thing that we didn't do in our project where we had some discussion around is one of the things you heard about is AI ops or machine learning ops, where you have an iterative process where you train your model, apply it to your data, see the confidence score, then tweak the model again, download it again, run it again. And potentially we could do the same on premises, right? You can just see how much your model has been applied or how much score you get with that model in your search index. And if it drops, then you could revert back to a previous version. Or if it increases, you can tweak it even more up until to the point where you can do like automated deployments of this stuff, right?
Or if like you said, you have a file share. So some files are from, I don't know, the sales department, other files are from the finance department. We can have two containers running depending on which one, which is the file coming from, and then run the model. Okay. Yeah, that's cool. Yeah. Cool stuff.
Cool.
How long did the project take? All right, it's a proof of concept, but how long did you?
Proof of concept, 10 days.
That's doable.
Hardest part of the proof of concept?
Well, that's basically our final slide.
Okay.
What would we have done differently? Between 80 and 95%, depending on what model we used, on our data set after just 10 days. The thing is, we are both not data scientists. So, especially me, I have no clue what things mean. I can tweak the buttons, but data science is actually a hard thing. I try to read up on it, but it's complex stuff. Yeah. So,
and then it would also cost not 10 days, but 100 days.
Yeah. But still, I think if you do a project like this, even though if you just spend 10 days, try to get a data scientist involved, at least to bring you up to speed on the core concept of things. That will definitely help. Second, once you start doing it, it's not only AI where you get interesting data from, but you can apply the data that you get from AI and combine it with data from other services. So in our case, we got a lot of data, and one of the key components that we retrieved was the author. And once you have an author, you can actually go to either your SharePoint user profile or go to CRM or whatever, and you can get additional data. So if you recognize an author and you're like 90% sure that it's that author, you can also get his email address and get that linked to that document that you have. So within the search index, you can then say, hey, I want to filter on all the content that author created, and it doesn't matter whether it was data that was stored in SharePoint or whether it was data that was still on the file share. Same, if you get a project number, you can go to project management tools or ERP to get additional data for that project. That's where it really gets interesting as far as I'm concerned. And we really should, well, download, retrain your model. It's an iterative process. You can always do better. Hitting the first 80% was easy. Going from 80 to 95 was what took us the longest, I guess.
The tweaking and tuning of the model, I guess.
Yeah.
Yeah, because you tweak it, it goes a little bit up, you tweak it again, it goes down.
Yeah, and then you test it with like 1% of your data, and all of a sudden you get 5% of the data, and you see completely different result because somebody forgot that the test set was from 90/45, while the actual data consists of data from 90/60 for 80%, things like that.
Okay.
But still, it's fun.
Yeah, and just a side note for this, Lewis works per app with one language. So ideally, we had a situation where the documents could be German or Dutch or English. So what we had to do as well is basically you get some kind of language service between the call to Lewis to understand what is the language and then point it to the right model and retrieve the entities.
Yeah.
That was out of scope for this, but that's something we should do in the future to make sure we support more languages.
Pretty easy. Bing translator, one call, and you get back the language.
Yeah. And the Azure text services can be downloaded as a model as well. So you could hit that. The thing with those models is that you'll probably end up with, I don't know, running 4 or 5 Docker containers for the different AI services that you want to use.
Yeah.
It's cool that they're all on-prem now. You always think it has to be in the cloud because it needs...
Not all, but most of them.
And the cool stuff is that they are containers now. So
you can run anywhere.
Think of run anywhere, and I think you already can run Azure Functions like with containers.
Yeah.
And so deployment and all those things, different ballgame than go back like 5 or 6 years.
Yeah. I remember I have to carry around a really large laptop with 32 gigs internal storage just to run SharePoint or RAM. And now I can just spin up something in Azure and work with it. And I can spin it up on my desktop at home. It doesn't really matter. I can even spin it up at Amazon because it's a container.
Yep. That's the really cool thing. And the deployment with Azure DevOps, the pipelines and releases, that's really cool.
Interesting stuff. So that's it for tonight.
Cool.
Cool use case, cool demo.
Yeah, that was nice.
Thanks.
Thanks for sharing.
Yep.
Thank you for listening. Make sure to check out the show notes at selectedtech.show to get all the mentioned references. And one more thing, please tweet about the podcast and give them a 5-star review. This really helps the guys a lot. Thank you and see you next time. Bye.